This is the polynomial review. So the first bit is dealing with the bounce wiggle cross, and if you really need some more time to think back on these and remember how these all work, you need to go back and watch the video. There's a video posted to Classroom that has all the bounce wiggle cross. I just reposted it just so that you have it. So if you need to go spend more time on this, that's a good place to go. So let's go ahead and start working this problem. And so when we're working this problem, we need to figure out which zeros are which. And so we need to take and first look at the equation. We need to split it up into parts. And so we're going to take that 7x squared and we're going to set it equal to 0. And we're going to solve for what our x is. And so first off, I need to divide by 7. X squared equals 0. I take the square root. Well, it's going to turn out every time there's a coefficient like this with an x, that's always going to be your 0. And so what exponent did that have? That had a 2. And then based upon our rules, if it's even, it's a bounce. Now we're going to go to the next one. And we're going to do x minus 1. Well, I could put this in parentheses and put a fourth power out here. But when I take the fourth root of 0, it is always going to be 0. So I don't need to take the time to do that. Add 1. And so x is equal to 1. So I'm going to go to my 1 column. That part had an exponent of 4. And so 4 is even, so it's a bounce. And then I'll do the x plus 1. And so the x plus 1 equals 0. Subtract 1. And so x is equal to negative 1. And if you just want to remember that it's always going to be the opposite of whatever that sign is, that also works. And so I'll go to the negative 1 column. Is that an exponent of 5? 5 is odd, non-1, so that means it's a wiggle. Now let's talk about what's happening. And so I need to add up and find my degree. So I take these numbers, add them up, and that gives me my degree. So if I add all those numbers, that's 7 plus 4 gives me 11. So this is the 11th degree. The leading coefficient, that's a 7. It was positive. So if it was positive odd, that means it went through something like this. So on the left-hand behavior, it's going to be down. So the y is going to be approaching negative infinity. On the right-hand behavior, it approaches positive infinity. So again, we're going to do the same process. And so like we talked about last time, the 5x, that's going to give you your 0. So that had an exponent of 1. And 1 is a cross. And then I'm going to go opposite sign. And so opposite positive 1 is negative 1. So this is going to be our negative 1 column. And the exponent on that was 7. So 7 is an odd, non-1, so it's a wiggle. And then the last one is my x minus 1, which will change into a x equals positive 1. The exponent on that is 4. 4 is even, so it's a bounce. I add those exponents all together, and I get a 12. So this is even. This is a 12th degree. And my leading coefficient was negative. So remember, when we have even, it's going to have all sorts of crazy stuff going on in the middle of it, but the front and the back of it, it's kind of like a soccer goal. They're both going to be approaching negative infinity. So y approaches negative infinity. So let's do this next one. Well, this next one doesn't have all of them. We are missing some of our terms. We're missing our positive 1. And so there are no, if I take and move this around, this is not going to get a positive 1. So there's none of them that have a positive 1 as the factor. And so the exponent, you can put NA, you can put 0. I don't care which way you go with that. Because basically there's nothing there that works. So none and 0 or none and not applicable, either way works. And then my 4x squared, that's going to give me my 0. Squared is the exponent. That's even, so it's a bounce. And then for my x plus 1, that's going to give me the negative 1. It has its exponent is 8. That's even, so it's a bounce. And so that degree is 10th. The leading coefficient on that is going to be positive. So it's positive, that's the football goal. All sorts of stuff may be going on in the middle of it, but the two ends are going to be going up. And then we'll go on to the last one. And our leading coefficient was negative on this one. But let's go ahead and look at each piece. We have all three pieces, so we're going to take and first look at our squared. Our squared had an our just factor that we factored out was a x term has a 7th degree. 7th is odd, so wiggle. And then we have our x minus 1, which is going to give us that positive 1. There's no exponent written, so that means the exponent is 1. That means it's a cross there. And then the last one is this x plus 10, or x plus 1 to the 10th power. And that's going to be that positive, or that negative 1, and that's going to give us a, because it's an even exponent, that's going to give you a bounce. We add all those together, and our degree is 18th. So we have another even degree with a leading coefficient that's negative. And so that is going to be your ones that look like something like this, where the two ends are pointing down. So this is like your soccer goal. And so the left end side is going to be approaching negative infinity, as well as the right hand side is going to be approaching negative infinity. So these next set, we're going to be going the other way. I give you the graph, and you need to go back to where you have the equation. So every single time it's a negative 1 up here, that means the factor that creates that is going to be the x plus 1 that we're going to be putting in parentheses. This is going to go with just the front, and this is going to be the x minus 1. And so I go back to my equation, and for the equation I have f of x equals, and now look at the shape of the graph. My two ends are going up, that means this is positive. And remember, if you have troubles telling, look on your right hand side. If it's positive on your right hand side, then the sign is going to be positive. So that means that my leading coefficient is any positive number I choose. I'm going to choose a positive 5. And then my x column, which is at x equals 0 column, it says my exponent on that is 1. So I'll stop there. And then I'm going to do my x plus 1 has an exponent of 5, and my x minus 1 has an exponent of 8. There's my equation. Now, these two are just looking at the graph. Was I going to positive or negative infinity? So there is nothing besides reading the graph that you have to do to get these two answers. They were going up, so they're going to positive infinity. The degree is the same thing we had before. You add those exponents. So 5 plus 1 is 6. 6 plus 8 is 14. And for them to be going up on both sides, we said that the leading coefficient had to be positive. Let's go on to the next one. So again, if you can't remember the rules, look at your right-hand side. It's going up, so that means that our leading coefficient is positive on this one. So again, I'm going to do f of x equals, choose a positive number, 10. And on this column, my exponent was 1, and so that means I have x to the first. And that's a 1, so that's a cross. Then we're going to do our x minus 1, and that's going to be x minus 1 whenever we move it over. Remember that became x plus 1, and that has an exponent of 9. Then we're going to do our x is equal to 1, which is going to be the x minus 1 column. That has an exponent of 7. So in our behaviors, we're just describing what's happening in the graph. So if I look at this graph, my left-hand side is going down, so that's going to be approaching negative infinity. My right-hand side is going up, so that's going to be approaching positive infinity. The right-hand side was positive, so that means our leading coefficient had to be positive. My degree came from adding these numbers, and that was 17. Going in and looking at another one. And so the x minus 1 will change into the x plus 1. The 0 is just going to be our x, and then our x equals 1 is going to become the x minus 1. So for exponent of 4, that means it's a bounce. Exponent of 8 is even again, so it's a bounce. Exponent of 3 is a wiggle. And based upon our graph, I look in the right-hand side, that's down, so that's negative. So our leading coefficient is negative. So I choose any negative number. So f of x is equal to any negative number. So I want to choose negative 3. X to the 8th. And then I have my x plus 1 raised to the 4th. And I have my x minus 1 raised to the 3rd. So looking at my graph, I can answer the next couple of questions. So the graph on the left-hand side was going up, so y approached positive infinity. On the right-hand side is going down, so y approached negative infinity. The degree, I add these up, and when I add those numbers up, I end up with 15. So again, we're going back to the same thing. We're looking at the graph. This one may have been a little bit hard to see. The tail does come straight down right here. So they're both going down. I don't have any of them with this x equals 1 as my intercept. So that means I'm not going to have that show up in the problem at all. If they're both going down, then that means my sign of my leading coefficient is negative. My left end behavior and my right end behavior are both approaching negative infinity. And so I'm now going to go ahead and go through each of the zeros. And so for the first one, x equals negative 1. That's when I had the x plus 1 as my factor. X equals 0 is when I just use the x. And so if exponent is 2, that's a bounce. If it's 1, or on the x plus 1 is a 6, that's getting a bounce. So we have 2 bounces in this case. And so f of x is equal to any negative number. So I'm going to choose negative 5. And then I do my x to the second and my x plus 1 to the 6th. And that's it on the bounce wiggle cross problems. And again, remember, I'm going to be doing 2 of each type, meaning there's only going to be 4 questions out of this section total. This next bit is going into what we've been doing last week, and we're going to be talking about what are your possible rational roots, possible positive. These are the ones that are dealing with Descartes' rule of signs. This is just dealing with the rational root theorem. I'm going to start with the rational root theorem. So to do that, we need our constant and our leading coefficient. And so what are my factors in my constant is 1 and 3. These are going to be your numerator. These are going to be your denominator. And then my denominator is going to be made up of the 1 and 5 factors. And so there's 2 in the top and 2 in the second. So that means if I multiply 2 times 2, I get 4. So that means there's going to be 4 possible choices for me to end up with. So plus or minus 1 fraction, plus or minus the second fraction, plus or minus the third fraction, and plus or minus the fourth fraction. And so I'm going to end up with my numerator having a 1 and 3. And my denominators need to be the 1 and 5s. And so what I do is I do it where I alternate back and forth each one, and then I do the next one where I keep it the same. So I'm going to do 1, 1, 5, 5. These two will simplify. So I'm going to go ahead and simplify those. And so when I simplify those, 1 over 1 becomes 1. 3 over 1 becomes 3. Everything else is the same. So those are my answers. The Descartes rule of signs takes me over to my problem, and I look to see of these numbers, do I have any sign changes? And so I look for my positives and my negatives. And so on this problem, I start off with positive all the way through, and then I switch over to negative. And so for my first of the possible positive, I don't do any changes of signs. I just do it straight out of the problem original. And there was only 1 sign change, so I had only 1 possible positive root. Next, I am going to replace all my x's with a negative x. And so I have 5 times negative x to the 5th plus 2 times negative x to the 4th plus 8 times negative x cubed plus 15 times negative x squared minus negative 8 times negative x minus 3. And so when I simplify that all down, anything with an odd exponent is going to change the signs. Anything with an even exponent doesn't change. So the only ones that are changed are the ones I put the arrow to the front. And so this becomes negative 5x to the 5th plus 2x to the 4th minus 8x cubed and plus 15x squared plus 8x minus 3. So I'm going to go through and I'm going to look for my sign changes that are happening. And so my positives are happening at these 2 locations, and my negatives are everywhere else. So I'm going to go through and I'm going to count my sign changes. 1, 2, 3, 4. I had 4 sign changes. So I have 4 possible negative roots, comma, and then you keep counting down by 2, so 2, 0. And then imaginary is the easiest one of all of those. You look at your exponent. If it's odd, you go down by 1. So it was 5, so I need to go down by 1. So I'm working with 4. And it's going to start with 4 and then count down by 2s. 2, 0. Imaginary is always going to have 0 as your last possible number. So again, we're going to start by dealing with our possible rational roots. And so my constant is at 25, so I have 25. I'm looking for the factors of those, which are 1 and 25 and 5 and 5. So I have 3 there. And then I look for my factors of the 3 from the leading coefficient, and that is 1 and 3. So I had 3 on the first one and 2 on the second one, so that gives me a total of 6 that I'm going to end up creating. And so I have plus or minus. I'm going to create 6 fractions to start with. And then I'm going to go through and 1, 1, 1, 3, 3, 3. And it really doesn't matter if you start with doing your numerator or your denominator first. As long as you have that whole pattern created. So I'm looking to see is there any of these that can reduce. And well, the first fractions can all reduce. Oops, I accidentally erased my denominator. And so that was a 1, 5, 25. None of the second row can reduce, so those are all my answers. So possible positive roots, that's when we're going back and we're looking to see the positives and negative sign changes. When are we having those? And so I'm just erasing what I had so I can see clearer. I had positive and I switched to negative, so I had 1 sign change. So I had 1 possible positive root. And that means when I test all those, if I get one of them that works, after I get 1, I don't have to keep testing my positives. My possible negative roots, I'm going to do the same thing, but this time I'm going to be plugging in a negative x. And so 3 times negative x cubed plus 5 times negative x squared minus 15 times negative x minus 25. And again, anytime that the odd exponent, that's when the sign will change. So it's going to be negative 3x squared plus negative 3x cubed plus 5x squared plus 15x minus 25. And so I'm looking for those sign changes. I'm positive in the middle and I'm negative on the 2 outside edges. So 1, 2 sign changes. So 2, 0, because we keep counting down by 2's. So I look for my highest power for the imaginary. So my highest power is a 3. I can't use a 3. I have to go down to the one right underneath it because it needs to be even. So 2, 0. Number 11. We're going to start off by finding our possible rational roots. That's when we take and are doing the leading coefficient divided by the constant divided by our leading coefficient. And so our constant in this case is a 1. So the only factors of 1 are 1. Our leading coefficient is 2, so 2 and 1. So this is only going to give us 2 possible sets. And so again, I'm going to write down my fractions, plus or minus, plus or minus. And our only numerator is going to be 1 and 1. And we have 2 and 1. And so this one can simplify to give me that 1. So those are my 2 answers. Don't forget those plus or minuses. So looking for our possible positive roots. Well, if I look at my problem, it's all positive. So that means that there is 0 positive roots I'll end up with. Now I'm going to plug it in and see what happens whenever I have a negative go into play in for x. So 2 times negative x cubed plus 2 times negative x squared plus negative x plus 1. It's going to change the sign on the first one, keep the sign on the second one, change the sign, keep the sign. So I'm looking for my positives when I'm a positive at those two places. And then I'm negative at these two places. So I have 1, 2, 3 sign changes. So I have 3, and I need to count down by 2, so the next number down is going to be 1. I can't go down to negative numbers, so that stops there. For my imaginary, I look at the highest exponent. It's 3. I can't use a 3. I have to go down to the even number right below it, so 2, 0. So this next one, we're trying to figure out our possible rational roots first. And so you're going to take your constant, 9. We're going to find all the factors of 9, which is going to be 1, 3, and 9. And we're going to divide that by all your factors of your leading coefficient, which was 2, which is 1 and 2. And so this time we're going to have 6 possible fractions. So I'm going to go ahead and write out my 6 fractions. And so the first row, I'm going to have 1s for all my denominators. The second one, I'm going to have 2s for all my denominators. And then let's go through and write out my numerators. And so I look to see, is there anything that can reduce? Well, 1 over 1 becomes 1. 3 over 1 becomes 3. 9 over 1 is the same thing as 9. And none of the other row can reduce, so that's my answers. So now we're going to find our, using the Descartes rule of signs, I'm going to look to see what are my possible sign changes. And so in this case, I start out with negative, go to positive, go back to negative, go back to positive, go back to negative. So I have 1, 2, 3, 4 sign changes. And count down by 2. Now I'm going to plug in a negative in for all my x's. So I have negative 2 times negative x to the 4th plus 9 times negative x cubed minus 5 times negative x squared plus 54 times negative x minus 9. And so it's changing, all of my odd exponents are going to change the sign in front of them. And so I have negative 2x to the 4th minus 9x cubed minus 5x squared minus 54x minus 9. So there are no sign changes there. So the negative roots is 0. And then I look at my highest exponent. In this case, it's a 4. So that means I start with 4 because it is even. Go down. This next bit, we're just going to be dividing. This is where we take our terms. We use the box. And so we're going to take the x and the 2 here. We're going to start with our 2x cubed. And 2x cubed divided by x is going to give me a 2, I wrote that in the wrong spot. Gives me a 2x squared that I could factor out of those, and I multiply, and that gives me a 4x squared. And what do I need to add to 4x squared to get to negative 5x squared? And that would be a negative 9x squared. The next one I'm going to do is going to give me the, I have to divide this by x, and that's going to give me my x term, so 9x. 9x times 2 is going to be negative 18x. So negative 18x plus what is going to give me that negative 16x. And that's going to be a positive 2x. I'm going to divide again on this case. and that's going to give me a 2. 2 times 2 is 4. 4 plus what is -5, and that would be a -9. So again, my answers are this L, or this top upside down or sideways L, whichever way you want to think about it. And so my answer is 2x squared minus 9x plus 2, and then our remainder. So our remainder, there's only one thing, so I go with the sign of the remainder. And then 9 divided by x plus 2. So let's look at this next one. This next one's a little bit harder because they are not in order, so I have to think about what the leading coefficient is, or leading highest exponent is, and that's going to be the first thing that goes in my box. If you don't like working with n's, change these to x's. I will not count off. And so my first one is going to be, I need to take and divide, and that gives me -7n squared. Multiply gives me 21n squared. 21n squared plus what gives me that 29n squared. And that would be an 8n squared. I'm going to divide, and that's going to give me a 8n. Multiply, and that gives me -24n. -24n plus what is going to give me that -16, and that would be a 8n. And then I'm going to divide, and that gives me 8. 8 times 3 is a -24. -24 plus what is going to give me -32, and that would be a -8. And so again, this L, or that sideways L, is what's going to help me get my answer. And so -7n squared plus 8n plus 8. And that remainder is negative, so a -8 divided by n minus 3. So let's look at this next one. They are in order. So the 10x cubed goes here. X and -3 goes here. So I'm going to divide first, and that gives me 10x squared, which gives me -30x squared. -30 plus what is that -22, and that would be an 8x squared that I need to add. I'm going to divide, and when I divide, I get an 8x. 8x times -3 is -24x. -24 plus what is going to give me -17, and that's going to be a 7. And we need to put the x with it, and take and factor out what can come out, or divide, and that gives us a 7. 7 times -3 is -21. -21 plus what is going to give me that -13, and that would be a +8. So when I go down to write my answer, it's 10x squared plus 8x plus 7. And this time it's positive, so it's going to be plus 8 divided by x minus 3. Let's do another one. The next two are going to have numbers where it's not an x that we're going to be dividing by. It's going to be a 3x or a 4x or whatever the term is. And so this one is 3x and a -10. And I started off with 3x cubed. And so I need to find out what would I need to divide. When I divide that, what do I come up with? And I came up with x squared. So that gives me 10x squared. And so 10x squared plus what gives me -19? And that'd be -9x squared. I divide that, and I come up with a -3x. And then multiply that times the -10, that gives me a 30x. And 30x plus what? It's going to give me that 33, and that would be a 3x. I'm going to divide, and that gives me a 1. 1 times -10 is -10. And -10 plus what is going to be that -9, and that would be a 1. And so again, this is a positive one. So I have x squared minus 3x plus 1 is positive, so a plus, and then the 3x minus 10 in the denominator. And so let's go for the next one. And so we have the 3x and the negative 4. So 3x cubed goes here. I'm going to divide, and that gives me an x squared. X squared times negative 4 is negative 4x squared. Plus what is going to give me that 23, and that would be a positive 27x squared. And then I want to divide, and that's going to give me a 9x. Multiply, that gives me a negative 36x. 36 plus, negative 36 plus what is negative 30? That would be a positive 6x. 6x divided by 3x is going to give me 2. 2 times negative 4 is negative 8. Negative 8 plus what is that negative 2? And that would be a 6. It was positive. So my answer is x squared plus 9x plus 2 plus 6 divided by 3x minus 4. This next one is a little bit trickier because we have to pay attention to the fact that there's a squared here, plus I'm missing my linear, so it needs to be rewritten as x squared plus x minus 1. The other thing that's missing is my x cubed over here, so it needs to be a 0x cubed that is for the 0x cubed. So go ahead and write in the things I have. Oops, that's supposed to be a 0x there. And we started off with the 5x to the 4th. And so I'm going to start the same way. I'm going to divide. And so I'm going to divide, and that gives me a 5x cubed. I multiply that times 0, and that gives me a 0x, excuse me, not x cubed, x squared. And that gives me a 0x cubed here. And then I am going to multiply 5x squared times negative 1. That gives me negative 5x squared. And so 0x squared plus what is going to be a 0x cubed? Or 0x cubed plus what's going to be 0x cubed? And that's going to be 0x cubed. And then I multiply, or divide, and that gives me a 0x up here. And multiply, that gives me a 0x squared. And then my next one is going to be a 0x. So basically this column doesn't, it's just a placeholder. Nothing's going to come out of that column. And then I'm going to keep going, and so I'm looking at my top, and negative 5x squared plus 0 plus what is going to give me a positive 5x squared, so that's 10x squared. And then I am going to divide, and that gives me 10. Multiply gives me 0x. And then I am going to multiply 10 times negative 1. That gives me negative 10. So 0 plus what gives me that negative 19? And that would be negative 19x. Negative 10 plus what gives me 5 and a positive 5. Oops, that should be a second. Yeah, and so that would be a positive 15. And so my answer is 5x squared plus 10 plus, anytime there's more than one thing in your remainder, you always just go ahead and put a plus. It's usually the best way to go. And that's your answer. And so the next bit is going to be the next 3 are where we're actually going through and finding the actual roots. And so we get to find our possible roots to start with. And so for our possible roots, we take our constant and we're dividing it by our leading coefficient. And since that leading coefficient is a 1, it's just the list of the factors of the constant. So 1, 2, and 4, but remember we're doing positive and negative. And then I'm going to look for the sign changes. So I'm looking to see for positive, I was from positive to negative, so there's only one sign change there. And then if I was to change all my signs for the negative route, this would become negative. That would stay with what it was. This would change to positive, and that would stay with what it was. And so there are 1, 2 sign changes, so 2, 0. And then the imaginary. The imaginary is going to be based upon our highest power, and then counting down. And I'm not going to count off if you don't give me this. These are just ways to help you find the easiest ways. And so when we're doing these, and for most of the test, there's only, or for 2 out of 3 questions, you're going to be able to just plug these in and test them in the calculator. And so when you test these in the calculator, that's when you're storing it in, and you're going, okay, I want to test a positive 1. I want to store that into x and then type in this equation. And the second time it should give you a 0. And when you test it, you end up with 1 working, -1 working, and a positive 4. Or excuse me, a -4 that worked. And so my actual roots, since I came up with 3 of them, I know that's all that I have, and I am not going to give you any with multiplicities on the test. So you will not be tricked by those. There will be some that there will be one that has either irrational or imaginary, but there will be none that have multiplicities. So we're going to do the same thing on this next one. So we're starting off by finding our possible roots. And since there's a 1 here, that means I just get to list the factors of my constant. And then I'm going to go through and look at my sign changes for my possible positive roots, possible negative roots, possible imaginary roots. And so on this one, for my positive, I only had 2 signs, and it changed once. So there's going to be 1 possible positive root. And then when I plug in the negative, that's going to make this negative. Nothing's going to change here. This changes sign. That stayed negative. So I had 1, 2. So 2, 0. And then for my imaginary, my highest power was 3. So counting down, I got 2, 0, because I can't start with 3. I have to start with an even number below. And so I go through and I test each of these in the calculator by plugging them in one at a time, like the 1 store x, and then typing in the equation and finding out when it's 0. And when you do that, you come up with -2 working, -1 working, and 2 working. And so those are my actual roots, -2, -1, 2. And so those 2, all I had to do is plug them in. And there'll be 2 of those on the test that you just have to plug in. The last one, we have our possible roots. And we have a little bit longer list this time, because we have, again, just a 1 here, but we have 12. And so I have plus or minus 1 and 12 combination, and then I have the plus or minus 2 and 6, and plus or minus 3 and 4. And so I have several to test. And then when you're going to go ahead and plug these in, you just keep testing them. And with these, you need to make sure that you get down to where you have 2 that work, because you have to get this 4 down lower. If that was a 3, you just need to find 1 that worked. And so when I do that, I find that -2 and +2 both work. So I know those are 2 of my actual roots. To find my other 2, I need to take and use my box method to help me see it. So I am going to do, and remember they go opposite sign when I make my factor. So x plus 2 is going to be my first one I'm going to work with. And I had x to the 4th. So when I divide that, I came up with x cubed. X cubed times 2 is going to be 2x cubed. And then I go up, and I need to get that to cancel out because there's no x cubes in that problem, so negative 2x cubed. And then divide, that gives me negative 2x squared. And then I am going to multiply, that gives me negative 4x squared. And I need to get that one down to where it is a negative 1, so a 3x squared. Then I'm going to divide, that gives me 3x. And then multiply, that gives me 6x. And to get I don't have any x's, so that needs to be a negative 6x. And dividing, that gives me negative 6. Negative 6 times 2 is going to be negative 12. And I didn't end up with a remainder, which is what the goal was. So this is my new thing that I'll be using for my next box. So I've tested out this one, got it simplified out. Now let's go ahead and go to the next box. I'm going to use this positive 2, which is going to come in as a negative 2. And so I'm going to start with this x cubed. Change out colors real quick because that helps. X cubed, I need to divide, and that gives me an x squared. X squared times negative 2 gives me negative 2x squared. Negative 2x squared, and I need to get to negative 2x squared. So that would be a 0x squared. And that's going to be a 0x. And this will make this a 0x down here. And I need to get the next one to 3x. So 3x. Divide gives me 3. Multiply gives me negative 6, which is what I was trying to get for my last number, so I did it correct. And so now I'm going to take this x squared plus 3 and set it equal to 0 and solve. So when I solve that, I need to take and subtract the 3 from both sides. And that gives me x squared is equal to a negative 3. Then when I take the square root of both sides, that negative comes out as imaginary. And so I have x equals equals plus or minus I on the square root of 3. So this next 2, we're going to be finding out if it's a factor. And so one of the ways to find out if it's a factor is to actually just divide it. And so we're going to take and divide this x of negative 6 into the problem. So x cubed, and go to the same place. And then we should end up, if it's correct, you'll end up with the remainder being 0. If the remainder is anything but 0, then it is not a factor. And so this one I'm going to show you how to do it this way, and the next one I'm going to show you how to do it using the factor theorem. So whichever way you like the best is the one you can use. So we divide it and we get x squared. This negative 6x squared. We want to get to that negative 13, so that means that we need to take and add in the negative 7x squared. And then we need to take and divide, and that gives us the negative 7x. Multiply, and that gives us a 42x. 42 plus what is going to be that positive 32, so negative 10x. And then I need to divide. And that gives us a negative 10. Negative 10 times negative 6 is going to be a positive 60. And that doesn't match up, so that means I'm going to have a remainder of negative 5. So that means this is not a factor. This next one, I'm going to show you how to do it using the factor theorem. So I'm going to take what I'm dividing by, set it equal to 0, and then I'm going to subtract 7. So p is equal to negative 7. negative 7 is what I'm going to plug in and see if it gives me a 0. If it gives me a 0, then I did it correct. And then that is a factor, so negative 7 cubed plus 10 times negative 7 squared plus 27 times negative 7 plus 42. And when I test that all out, I get a 0. So that means this is a factor.